one kid who passed up money. He chose quantum entanglement because it was something that bewildered him. And now I stand before you, hoping to interest you the same way that this topic has enticed me. But before I begin with all of the complicated theories and pop culture references, let me first explain what quantum entanglement is. Imagine a long-distance relationship, but instead of being separated by miles, you're separated by space and time. You have two particles, invisibly connected across vast distances. And normally, connection between these particles can take years, decades, even centuries. But with quantum entanglement, it's instantaneous. Now let's think about this for a second. The speed of light is universally considered to be the speed limit of the universe. Nothing is faster than light. Light is fast. 186,000 miles per second. That means that light can go around the Earth 7.5 times in a second. There it went again. However, on a galactic level, this is agonizingly slow. Light that is leaving the sun right now will take 6 hours before it even lands at Pluto. And for it to get to the other side of the galaxy, over 200,000 years. That means that light that we see now, that left a star on the other side of the galaxy, left that star when humans were first evolving in Africa. However, quantum entanglement allows the interaction between these two particles of the same distance to be instantaneous. This phenomenon is experimentally proven. Caltech likes to explain it by seeing a dance and seeing one dancer in a pirouette, and automatically knowing that the other dancer is also performing a pirouette. The beauty of entanglement is knowing the state of one particle by just looking at its companion. There are many different ways that particles can behave. For example, one thing that can be measured is their spin. If one spins up, the other spin is down. Spin is a fundamental property of these particles, like their mass or their color, not a physical spin. Likewise, polarization is something that can be measured. Polarization is the direction a photon wiggles as it travels. This can be up or down, side to side, all over the place, or a mix of any of them. These two properties, spin and polarization, are perfectly correlated between particles no matter the distance of them. Now that we know what quantum entanglement is, let's talk about its portrayal in the media. Can I get a show of hands? Who here has seen the Marvels? Yeah. In the Marvels, the three main characters are connected for the majority of the movie. In the event that they use their powers at the same time, they instantly switch places. This mirrors quantum entanglement, as particles in space are correlated perfectly. The Marvel Cinematic Universe continues to allude to quantum entanglement through its movie Ant-Man and the Wasp with the quantum realm. The quantum realm is how Marvel decides to portray these different theories and propositions. Because quantum entanglement is so complex and there are so many unanswered questions, there's a lot of questions that do end up arising. Many surrounding time travel, space travel, and just connection overall. Unfortunately, time travel is not a possibility. The use of quantum entanglement is to harness interconnected particles for revolutionary technologies. Quantum computing, quantum sensing, quantum cryptography, which are all great avenues for creative doom scrolling. Overall, the use of quantum entanglement will benefit scientists in understanding this universe and opening doors that were previously closed. Now, I know I just threw a lot of information on you, so let's look at the big picture. What can we take away from this? We started with this idea that nothing in this universe is truly separate and without signals, just instant connection. And that Albert Einstein, one of the smartest men to ever live, looked at that and went, yeah, that's spooky, which honestly makes me feel a lot better as someone who has never even taken a physics class. But maybe that's the point. Maybe quantum entanglement isn't just about the particles, it's about the perspective. It reminds us that the universe doesn't always follow the rules that we expect it to, that there is more than just the connection. So, if the universe can break its own rules, ignore space, ignore distance, ignore time, and still work perfectly in sync, maybe we're okay with not having everything figured out too. And who knows, maybe somewhere across the galaxy, there are two